So Shahid has also joined. Only Madiha is left. So let us start, and in the meanwhile, she will join. Right. So what we were discussing in the previous class. Oh, what happened? Okay, very good. Yeah. So we were solving this question, right? And we drew the free body diagram of the two independent objects. So any doubt in this one, guys? Any doubt in this one?
No, sir.
Okay, so yeah, this was, so we had two free body diagrams. One was for this one, all the forces we accounted for, and then this was the thing, right? And then this was the free body diagram of the other one. So we have these two equations, right? And we have to get rid of t, right? We have to find out this a. So this is 4, right? So this is 4a, and we can also, yeah. So how much is this thing? Right, we have two equations. One is t minus 2g equals to 2a, right? Let me check this again. So yeah, this was t minus 2g equals to 2a. And then this was 8g, so m into a, 8 into a by 2, and then 8g minus 2t. So these were two equations, right? Now I have to get rid of t, so I will multiply this equation by 2. So this would become 2t minus 4g, then this is 4a, and then we have 8g minus 2t equals to 4a. So now we will add these two equations, right? This is, let's say, equation third, and this is equation second. So if we add these two, so this will cancel, right? This plus this. So this would become 4g, and this is 8a. So what is a? A is then 4g by 8. So this is g by 2. G is 10. So this is 5. So A is 5 meter per second square. Right. So this is accelerating with 5 meter per second square. And this is accelerating in the downward direction with a by 2. So this is 5 by 2 meter per second square. Right. So we have acceleration, which is 5 by 2 meter per second square. This is a. And then we have this distance. And we have initial velocity 0 and final velocity. What was the time? Calculate the time taken by box of 8 kg. Yeah, so we have to apply the second equation of motion. So S is ut plus half at square. S is how much? This is 0.2 meter that this has to cover. Initial velocity is 0. Half A is 5 by 2 and t square. So how much is t square we have to find? So all these things will go in the other side. So this is how much? 4 into 0.2 divided by 5. And this is t square. So yeah, so this is 2, and then what would be this? 0.8 divided by 5. So this is how much? This is 50. So 4 by 25, right? This is 4. and then this is 25. So 4 by 25, so T would be 2 by 5, which is 0. So this is the time. Is it clear, everyone? Yes, guys, is
Yes.
it?
Yes, sir.
Yeah, then quickly note it down and then we'll do the next question. So I was talking about a peculiar question that we did yesterday. So I will continue from there. Yeah, so this A and this A is different, right? This is actually A by 2, but I should have written A prime, but yeah, you guys can understand. Yes, whenever you guys have noted, please tell me. Yeah, so, okay, so noted. Now let us do the next question, and which is based on this one. So this question we did yesterday. We did this question. So there is a similar question based on this thing, right? And that is a little bit complicated one. So we will discuss that question in here. And I will skip some of the questions as well. But yeah. So this is the question. So we have this similar case, right? As we understood in this one. So we have similar case, and yeah, so let's see what happens, right? But there are numerous, because in this case, mass was not moving, right? This mass was fixed. But in this case, the mass is moving. So we have different complicated scenarios, right? So we have this thing, right? So first we have a block of mass m slides on the wooden wedge, which in turn slides backward on the horizontal surface. The acceleration of the block with respect to the wedge is, right? So we have to find out this acceleration. What is the acceleration of this thing? So we have to apply the free body diagrams, Newton's second law, all of the things we have to apply, and then we have to find the answer, right? But first, let us find out the acceleration for this thing, relation of acceleration for this mass, which is moving in this direction, right? So we have so first case is that only wedge is mu. And this is the mass, so we will not consider this mass. Only it will cooperate, or only it will contribute to the normal reaction. So we have this normal reaction and this angle, right. So we know that this angle is how much? This is theta. So this is theta, right? This is 30. So this is again 30. And this would be 60. And then there is this acceleration of this wedge. So let's say this is A prime. And this is A prime, and this is normal reaction. So if we calculate this A prime, right, if we write the components of this N, so it will have this horizontal component and it will have this vertical component. So this horizontal component would be equal to this A prime, right? So A prime, let's say M, whatever this M is, MA prime is N cos 60. So A prime is how much? That is N, right? And cos 60 divided by this N. So this is the acceleration, right? Or we can write this N as A prime by cos 60. Right, so we have this relation. And we will use this relation in the whole free body diagram. So now let us consider this block, right? Now let us consider this block and we will write everything. So we have this block and this is accelerating in this direction, right? This is theta. And this block has this mass, right? This has this normal reaction. And this is the angle. This angle is theta. And we have this component, right? So this is the component mg and sine theta. And this is the component mg cos theta. So we have this thing. Now, because the acceleration is in this way, right? So we have to consider the pseudo force. What would be the direction of the pseudo force? Yes. What would be the direction of the pseudo force? So we have to take in the opposite direction. So this is the mass m, so m a prime. This is f pseudo. Right, and with this, we know this a prime. What is this a prime? So we have this angle. This is 90 minus theta. So this is theta. Right, this is theta. So this would be how much? This is m a prime and cos theta. And then we have this thing, m a prime and sine theta. Right. So these are the things. Right. Is it clear, everyone? Is it clear, guys?
Yes, sir.
Okay, so now we have written everything, and we know that, right? What do we know? So we have to find this A. The idea is that we have to find this A, right? Now we know that this mg cos theta is how much? So this is a vertical component. vertical part. In vertical part, what we will apply? Equilibrium condition or Newton's law? Second law. What we will apply? Yes. Vertical part. So this is not moving in here, right? This is not going upwards or downward. This is sliding in this direction. So this part, the vertical motion is fixed. Yeah, so we will apply equilibrium, which means that the upper part or the upper force is upward force is equal to the downward force. So N plus MA prime sine theta, this is equal to mg cos theta, right? And remember, so, where did I write? N is A prime M. So this is capital M, mass of the wedge, right? Okay, so yeah, so this is the thing, and we know that what is this N. So this is A prime. What was the mass of the wedge? So mass of the wedge is 16 kg. So this is 16 divided by this cos 60, which is half. So this is in, and this is sine of 30. And then we have mg. So mass of this small thing is how much? 8. So 8 into 10 into cos 30. So how much is this thing? A prime, then 16, and then 2, and then 1 by 2. And then this is 8 into 10 into cos 30 is 1 by 2. So this 2 and this 2 cancels. This is 4. And A prime is how much? This is 4 into 10 divided by 16. So 4, 4 is 16, and then we have 2 and 5. So 5 by 2 meter per second square. This is A prime. But we want to calculate this A, right? So we know that what would be this A. So in the horizontal part, we have to apply Newton's law, right? For this wedge, this block, for this block, we have to apply the Newton's second law. So summation of F is MA, and we know that what are the forces. So all these are in the same direction. So mg sine theta and plus ma prime. A prime now we know. That is 5 by 2 and cos theta. This is equal to ma. So m and m will cancel. Right. So what would be this thing? So g sine theta is sine 30 plus 5 by 2 cos 30, which is root 3 by 2. This is your A. So this is 10 by half. This is 5 plus 5 root 3 by 4. So how much is this thing? This is A. 5 we can take common, 1 plus root 3 by 4. So what was the answer in here? Oh. Oh, they have written in the form of G. Why? So why this is written in the form of G? Okay, so yeah, they have written in the form of G, but this answer is also correct, right? This answer is also correct, and we are getting root 3. Okay, so we have to keep this G everywhere, right? Yeah, but this is also the correct answer, right? You keep this G and you will get the answer as well. So this was the idea of this question. Is it clear? Who got disconnected? I saw so many people got disconnected. So Tarif, yeah, Tarif has come back. So is it clear, everyone? Is it clear? Yes, guys, is it clear? Yes, everyone, is it clear? Do you guys have any doubts? Or should we do this with by keeping this G? Yes, everyone, is it clear? These two diagrams are important. If you can understand these two diagrams, then the answer would be simple. So, yeah. Can I do it once again? Okay, so let's do this question once again, but keeping this G, right? So Maria is saying that we should do this question again. So let us do this question again, right? But this time we'll keep this G. Okay, so let's keep this G. Yeah. Oh, so this diagram is okay. Let us see this. Okay, so now let us do this question again. So what was this diagram? I guess this was the diagram, right? Or what was the diagram? So this was the diagram. So firstly, this wedge is moving, right? This wedge is moving in this direction. So this was the acceleration, right? And now we have this normal reaction at this point, right? So this normal reaction, we can decompose it in two parts. So this is the acceleration, which is the acceleration of the wedge. And this angle is 30 degrees, so this angle would be 30 degrees. So this normal reaction will have two components, n cos 60 and this n sine 60. So this A prime, this would be equal to N, right? So this MA prime, this is equal to N cos 60. So we have this A prime, which is, so this A prime is N cos 60 divided by M. So this is A prime, right? Now, this block is there. This block is moving. So we will write every forces which are acting on this block. But this block is in this wedge. And this wedge is also moving. So we have an accelerated frame, right? This frame is moving in this direction. So we will consider a pseudo force in this direction. So this would be the pseudo force. And we know that this is mg. This angle is theta. So this will have two component, mg cos theta and mg sin theta. Right. And then also we have this pseudo force ma. So this is this will also have two components. This will have this component, right, which is cos theta component, and then this sine theta component. So these are the components that we have. And then we have this normal reaction. So these are the forces which are acting on this block. And we have to find out this A. So let us solve this thing, right? So if we write the vertical part in here, so for vertical part, what do we have? We have n plus ma prime sine theta. This is mg cos theta. And these are small m, right? So this is the first thing, right? And then what do we have? And then we have, this is first equation. And for horizontal part, what do we have? For horizontal part, we have MA. This is equal to mg sine theta. And this is MA prime cos theta. Right, so these are the two equations. Up to this point, is it clear, guys? Is it clear up to this point? Yes, guys, is it clear up to this point?
Yes, sir.
Okay, so now we can find out the value of n from here, right? We know that n would be how much? So n is a prime m by cos 60. Cos 60 is half, so this is 2a prime. Right. So we will put this value in here. So this is 2a prime m. And then we have what? Right. So this is m a sine theta. And then mg cos theta. So this is the first equation. Right, and then we have the second equation, MA, which is mg sine theta plus MA prime cos theta. So we have two equations, right? We have two equations, and we want to find out this A. So we have to find out the value of this A prime from this equation, right? So what is this A prime? This A prime, if we take it common, so this is 2m plus m sine theta. Right, and this is mg cos theta. So how much is this thing? 2m, which is 2 into 16. Right, so mg cos theta divided by 2 into 16 plus this is what, 8. And sine theta, sine 30 is half. So this is the thing. So how much is this thing? So m, which is 8, g, and root 3 by 2. Divided by, we have 32 plus 4, 36. So 8g root 3 by 2 and 36. So 4 2s are and 4 9s are. So 2 root 3 by 9g. This is A prime. And if we put this value in here, right? So if we put this value in here, so what we will get? So we have m, and in this one, m will cancel. So we have A, which is g sine theta, right? Sine theta is half. And then A prime, which is 2 root 3 by 9. And then g. So g is, we have to put this g and then cos theta, which is root 3 by 2. So this 2 and this 2 will cancel. We have g by 2 plus This is root 3 into root 3, 3. So this is 3. So this is G by 3. Right. So how much is this thing? 6. And this is 5G by 6. So A is 5G by 6. Oh, so we don't have any option in here, right? Yeah. So what did I miss? So this should be 5G by 6, right? Not 6G by 5. So there should be a correction here. Right. If I check my calculation again, so this is 1632 plus 4, 36. So this is correct. This is 8 into G root 3 by 2. So, oh, yes. So this 2 is here, right? This 2 is also there. So we have root 3 by 2. So this 2 will cancel, and this is root 3 by 9 only. So this is root 3 by 9. So we have, right. So we have root 3 by 9 only. So how much is this thing? So root 3 by 9, so this is 3, and this 2 is here. So this 2 is here. So this is 6. Yes. So this is 6. And we have what? So the LCM is 6. This is 2 3 ja, and this is 3 2 ja. So, okay. And then this is 6. So 4G by 6. So 2 by 3. 2G by 3. So this is the option. Now do we have the option? So 2 3 by G. This is the option. So is it clear? Without the G, that was pretty easy. Right? So if we have to keep this G, then this calculation becomes linear. So if we only put the value of G, then this would become easy calculation. But I don't know why they have put this G in here. So if we miss one term, then the whole answer would be different, right? But luckily we got the term right. Okay, this has taken a lot of time, but yeah, just quickly do this one. Just quickly note it down. If you guys have any doubt, please tell. But I'll watch the recording. So, okay, yes. All the best, Iftar, Yad. And where are you going for your iftar party? So, in the family, or you are going somewhere else with your friends? With family. Okay, yes. All the best. All the best. Yeah, then yeah. So see you in the next class. Right, you have to. Iyad is going for iftar party, so family and friends. Yes. Okay, enjoy, Iyad. Enjoy, but please do watch the video, right? Afterwards, whenever you get time. Okay, rest of the you guys, please note it down. Rest of you guys, please note it down. And if you guys have still some doubts, please tell me. So this uses the same idea, but this part was important because if we don't know what is this A prime, or if we don't know what is this normal reaction, then we won't be able to solve this thing. So this was the crucial point, and then we apply this pseudo force in here. We are only considering the block's mass. So every mass is small m in here. Only the wedge mass we are considering here. So quickly note it down, guys, and please tell me if you have any doubt in this one. Now, whenever you guys have noted it down, please tell me. Remember, in inclined plane, normally in inclined plane, this is not your x and y axis. Your x and y axis are these ones. So this is your x, this is your y. Similarly, you saw that this is your x, this is your y axis. So whenever I'm talking about vertical part, so this is the vertical part. Whenever I'm talking about horizontal, so this is horizontal. Yeah, whenever you guys have noted it down, please tell me. Yeah, whenever you guys have noted, please tell me. Done. Okay, so everyone are noted. So let us do the next question, right? I will skip some questions. So let me see if, right, parallel to the above is suspending. So this one, yeah, I'll skip some questions. And yeah, this question is important. So this question is important. So we'll quickly do this question and then we will move on to friction. So a mass of 10 kg is suspended by a rope of length 4 meter from the ceiling, right? So we have this mass, right? And this mass is suspended by a rope, and this length is 4 meter, right? So this is this thing. A force F is applied horizontally at the midpoint of the rope. So this is the midpoint of the rope, and a horizontal thing is applied, right? So now of the rope such that the top half of the rope makes an angle of 45 degree with the vertical. So now we have stretched this thing. So this will, right. So this will become like this. So then this will become this, right? And this is the force. And this is making an angle, how much? So this is 45 degree. So this is how much? 45 degree. This is the rope, right? This is the rope, so it will experience a tension. So this is the tension, right? And this is the tension. So this is the tension, this is mg, right? Now, what is balancing this force, right? So we have two components of tension. Please solve this thing and tell me what is the answer you guys are getting. So you guys have to find out what is this F. Remember, this is equilibrium. Right, this is equilibrium, so nothing is moving. So you guys have to find out what is this thing, right? What is this F? So you have this tension, it will have two components, this one, right? So at this point, what is F? Yeah, please solve this question. Everything is there. Please solve this one and please tell me what is the answer you guys are getting. So you have to just resolve this tension component and then you guys have to find out what is the answer. So Tarif is saying C option. 100 newtons. So Maria is also getting C option, right? Yes, rest of you guys. Shahid and Fadil, what about you guys? What is the answer you guys are getting? Yes, Shahid and Fadil. What is the answer you guys are getting? So everything is there, right? At this point, you have to draw the free body diagram. So F is simply this component, T sine 45. Right, so F is simply T sine 45. And you have to calculate this T. So this T is simply mg. So mg sine 45. Right, so how much is this thing? So you have M, which is 10, G is 10, and then, yeah, so what is sine 45? 1 by root 2. Okay, so yeah, so this part is T cos, right? So this is T cos 45. So T cos 45 is mg, right? So T is mg by cos 45. Okay, so this is T is mg by cos 45. So you have 100 into tan 45, which is 100. So this would be your answer, right? 100 Newton. So is it clear, Shahid and Fadil? Is it clear? Okay, so now we'll move on to the next topic, which is friction. So as you guys have learned, right, there are different kinds of friction. So this question I will leave to you, right? I will leave this question for you guys, and you guys please try this one. But let us move on with friction, right? So you have this friction, right? And then there are two kinds of friction. One is in the solids, and then you have fluids. So in fluids, this is called viscosity. And in solids, you have two kinds of friction, sliding and rolling. Rolling is not there, right? Rolling friction is not there. So we are only talking about sliding friction. So sliding has three parts, static, limiting, and kinetic. So limiting is just the maximum value of the static one. Right? This is the critical point in which the body starts to move. So in these three, which one is the adjustable friction? Can you guys tell me that in these three, which one is the adjustable friction? Which one is the adjustable? So it can adjust, right? It can adjust itself that it becomes different. So which one is the adjustable friction? If you guys remember, you guys have studied this friction, right? Static, kinetic. So Shahid is saying kinetic. Maria is saying static. Right. So this friction is adjustable. So let's say that if you have this sofa, very heavy sofa, right? How do I make this sofa? So let's say you have this sofa and someone is applying some pressure, right? It has some coefficient of friction, and let's say that its limiting friction is 50 Newton, right? So let's say if this person is applying 10 Newton force, then this sofa will apply the same force, 10 Newton. So static friction is 10 Newton, right? And then if it is applying, let's say, 20 Newton force. So again, this would apply the same force, 20 Newton. So this static friction, right? This is adjustable. That is why you have this less than equal to, right? So it is changing depending upon the force that you apply. So until and unless it reaches this 50 Newton, so then this static force becomes maximum, and that is equal to the limiting friction. So that is why this is adjustable, right? So this can adjust depending upon the force that you are applying, right? So this is about the static friction, and this is equal to In all the cases, I will be talking about, I will writing the static friction, but I will writing the maximum value. So I'll be writing limiting friction, and this is mu S or mu L N. So this is the thing that I will be writing, right? And yeah, oh, what are these things? Okay, so we have all these things. So yeah, let's understand all the free body diagram of a limiting friction, right? On an inclined plane. On an inclined plane, let's understand the free body diagram. And this is with friction. Right, so if we can make this diagram, all the answer would be pretty much simple to understand. So if we can make this diagram, then all the answers becomes easy to understand. So let's say this is theta, right? We have this block, and this is mg, always downwards. This is normal reaction, right? Now it will have two components. This mg will have two components. This is theta. So this is mg cos theta. And this is mg sin theta. Right. So now this block should, because only this force is acting. Right. This normal reaction is balancing this component. So this normal reaction is balancing all these components. So we know that only this component is there, which means that this has to move in this direction. But this is static, right? This is static, or this is at equilibrium. So which means that there is some other force which is acting on this thing. So that should be in this direction. And that is your friction. Right. So if we write the free body diagram of this thing, or if we write the vertical and horizontal component, so vertical component is what? Vertical component is simply n is mg cos theta, and we have the horizontal component. So horizontal component is what? Horizontal component is f, and this is mg cos theta, mg sin theta. And we know that this f is mu n, right? And we also know that this n is mg cos theta. So mg cancels, and this mu s is simply tan theta. So this is your friction, coefficient of friction for the inclined block, right? So this is kept on this inclined plane. So quickly write this thing, and depending upon these things, we'll solve all the questions, right? So if we can make this free body diagram quickly, then all the answers would be easy for us. Quickly note it down, and whenever you guys have noted, please tell me. So in the question, you have to be very careful that if they are mentioning with or without friction. So if they have mentioned friction, then you have to write everything. So we'll come to this part quickly, but we have a couple of questions that we have to do. So quickly note down this one, guys. Quickly, we have a very short amount of time. Yes, noted everyone.
1 minute.
Okay, yeah, quickly note it down, Tarif, and then we will do some questions. Yes, Tarif, noted.
Yes, sir.
Yeah, so remember, whenever they say that the surface is frictionless, then this F would not be here, right? So this will slide down. So we will do some question based on this one, but yeah, we'll do that later. But let us do some questions from friction, right? So yeah, this one is. So this is the inclined plane one. We'll talk about this thing later. But let us do two questions which are very, very, very important. Okay. So we have, right, we have this table and this is frictionless. Right, so this table is frictionless. And there are two blocks which are kept, right? This is 2 kg, this is 1 kg. And now this block is given, so this whole block is given F force, right? This is frictionless, so this block is given the F force, right? So it will keep this, so this block will go along with this thing. So if I write the free body diagram of this thing, so what would be the forces? Let's say one is gravitation, mg. The other one is normal reaction due to this one, right? And what would be the other force? What would be the other force? Can you guys tell me? Remember, this is kept on this thing. So what would be the other forces? Or let me talk about first thing is that what is the frame of this thing? What is the frame of this thing? This is just like the previous cases, right? So this is kept on this thing and this is accelerating, right, in this direction. So which means that we will have a pseudo force. We will have a pseudo force in this direction. So we have we have a pseudo force in this direction, which means that friction would be where? Where would be the friction? So friction is in this direction, right? So this is the direction of friction. And you will see that this is along the direction of this force, right? So sometimes whenever you apply some force, so friction is along the direction of this force. And that is making this thing to move, right? Otherwise, it will, if this thing is frictionless, then due to inertia, this thing will go down, right? It will drop. This will go in this direction. This doesn't have any friction, so this will not go in this direction. It will drop down. So due to this friction, this thing is moving, right? Is it clear? Is it clear? Yes, is it clear, guys? Okay, good. So now we have to find out what is, because we are talking about this block, so we have to write everything in terms of this thing. So F pseudo is this mass, right? Let's say that is M1. M1A, that would be equal to F, right? So this is equal to F. So what is F? This is mu S N, right? And how much is this thing? So this is M1, this is A, this is mu S, this is M1 and G. So this thing will cancel and A is how much? Mu S is, how much is mu S? 0.5 and G is 10. So this is 5. So acceleration is 5 meter per second square. So you have found out what is the direction of, what is the acceleration in this direction. And now you have to just calculate the force. So the force would be due to this whole thing, right? So this F is M total and then into acceleration. And this is how much? M total is 1 plus 2 and then A, that is 5. So this is 3 into 5, which is 15 Newton. So this was the question, right? But luckily we didn't have any friction in the table. So that is why we don't have any complicated thing in the downward path. But we'll see a question in which we have the friction in the downward part as well. So we'll solve that thing as well. But is this thing clear to everyone? Why we applied this pseudo force and why we got this M total and everything? Is it clear, everyone? Good. So this is for small block, right? So this is, and then we solve for the whole block, right? So yeah, quickly note it down, guys, and then we'll do the next question. Quickly note it down. And there's a similar question related with this one. So that we'll do, and then we'll talk about the inclined plane one. Whenever you guys have noted, please tell me. So this idea is very, very important because you guys have thought that force is in this direction, so friction would be in this direction, right? But that is not the case for this block because this is in the accelerating frame. So we'll have to consider pseudo force and then the friction direction. Yeah, noted everyone. Okay. Noted. So now let us talk about another similar question. What happens when we have friction in this part as well? So if we have friction in this part as well, so we'll have acceleration in this direction, and then we have the force of this block in this direction, and then we'll have friction in this direction. So everything we will calculate. So let us check that question. Yeah. So now we have different scenarios, right? So we have everything. This table has also, right? So this table also has some friction. So we have this block B and the upper block A. So again, we'll do the exact same calculation, but let's say we have this acceleration, right? And this force on this B block is only F, right? So this will have some friction in this direction, let's say F1. And again, if we talk about this A block, so A block will experience some pseudo force, right? So this is F pseudo, and will the calculation would be exactly the same. Oh, Tarif has also calculated B. Yeah, so let us check. Let us check the answer, right? Let us check the answer. So we have on this A block, on block A, right? We have this normal reaction, and we have this Mg, and then we have this friction F2, right? So what do we have? We have F2, which is F pseudo. So we know that how much is F pseudo? F pseudo is MA. And F2 is how much? Mu S N. N is mg. So again, we will cancel this thing. And A is mu S is 0.2. And G is 10. So this is 2. So A is 2 meter per second square. This is 2 meter per second square. Now, if we write the free body diagram on block B, right? So what would be that thing? So we have a summation of F, that is MA, right? And how much would be this F? So F is this direction F minus this F1, right? And this is MA. But if we calculate this F1, right, so this F1 would be due to the normal reaction, right? So F minus this mu S and N, let's say prime. And this N prime would be due to this whole block, right? So this due to this whole block. So that would be M plus mg, right? So our F is simply MA plus mu S and M plus mg. So how much is this thing? This this M is, how much is this one? So this is B, which is 3 kg. So 3A, which is 2, right? Plus, because this whole block is moving, right? So this whole block is moving, so this should be M plus M as well, right? So this is 4. And this is 4 into 2. And this is 0 0.2. And then this is 4. And then this is 10. So how much is this thing? So this is 8. And this is 8 as well. So 16 Newton. Right. So that would be the answer, 16 Newton. Yes. So Tarif got the right answer. Is it clear, everyone? Is it clear? Yes, guys. Is it clear? So this acceleration is happening for the whole thing, right? So let me write it as M plus M as well. Otherwise, it would be very, right, confusing. So this is M plus MA. This is M plus MA. This is M plus M. Because this thing is moving as a whole, right? This whole thing is moving, so this is accelerating with 2. So this whole thing will have the acceleration. Okay. But if we talk about for the case of block A only, so then we have to write only this block M mass. So that is the key idea in this question. Is it clear, everyone? Yes, guys, do you guys have any doubt? Please tell me. Otherwise, quickly note it down. Yeah, whenever you guys have noted, please tell me. So this is a complicated system, right? One friction is in this direction, the other friction is this direction, and these two friction are keeping these two blocks together, right? So these frictions are very important. And due to friction, right, you can walk on Earth's surface. So that is why these frictions are very important. Yes, whenever you guys have noted it down, please tell me. Done. Okay, so what about rest of you guys? Maria has noted. So what about rest of you guys? Noted. Okay, I guess you guys have noted. So now let us do that inclined plane question. Right. So now we can do this inclined plane question. And yeah, so this question I will again, I will give this question, I will leave it for you guys, and then we will do these questions, right? But let us first do this inclined plane. Okay. So now I will ask the components, right? Because you guys already know. So now I will ask you guys the components, right? When a body slides down from rest along a smooth inclined plane, making an angle 30° with the horizontal, it takes time t, right? So case first. What is happening? Yeah, so case first, smooth plane means no friction, right? So we have no friction, and then what would be the diagram? So we have this thing, right? Let's say this is G, this is theta, and for our case, this is 30°. So we'll take this 30° later. This is theta, this is mg cos theta, and this is mg sine theta. This is moving in this direction, and this is the normal reaction. So if we write the horizontal component only, so for horizontal component, right? For horizontal component, what would be the, will it be equilibrium or will it be Newton's law? Will it be, what it will be? Yes, for the horizontal component, we have to write what? Equilibrium or Newton's law? Yes, Tarif, Maria, and Fadil. What we have to write? Newton's law, right? So this is second law. So we have MA is mg sine theta, and we don't have anything else, right? We don't have anything else, so this is the only thing. So this is A, and this is G sine theta, right? You can see that this is a constant. Angle is the theta is constant, G is constant. So this A is uniform. So this is covering, right? It is moving with rest. U is 0. And it is covering, let's say, some S distance. Right? This is S and T is T. So if we write, if we calculate this distance, right, this is ut plus half at square. This part will cancel, and a we know that is g sine theta t square. So s is this thing. This is case first. In second case, I am writing in the same diagram. In the second case, we have this part only, this friction, right? So again, second case with the friction. So if we write second law, right, in horizontal component, then what do we have? We have MA, that is, what is the second law, Tarif? What would be second law? Yeah, in this case, what would be second law? Yes, Tarif, are you there? What would be second law? Hmm? Where is Tarif? Okay, Maria,
Here.
you please. Oh, you are here. So please tell me what would be the second law?
Sir, inertia.
Yes,
Sir, inertia.
inertia? No, I'm asking about in the horizontal component. I have to write. Yes,
Okay.
Maria, you are correct. I have to write the second law. What would be that? This thing you have, yeah, you solved so many questions. So this you should know, right? This is the most important thing, sign convention. What is in the direction of acceleration? Mg sine theta. That is positive. And then F is in the opposite direction. So F. F is mu Sn. Right. F is mu S and N. N is what? N is mg cos theta. So M we can cancel. A is, this M is cancelled. G sine theta minus mu S cos theta. And theta we know, right? Theta we can put because theta is 30 degree. So let us write the value of theta as well. G sine 30 is 1 by 2 t square. So this is G by 4 t square. Right. And what is this thing? So this is A G by 2 minus mu S root 3 by 2. And there is G also, right? So this is A. Now we know this acceleration is also constant, uniform. So what would be the distance? Let's say distance is S, same. Time they have given, given alpha into t. And what is u is 0. So if we write distance, that is half at square, right? So S is S we know. S is gt square by 4, and that is capital T, right? So this is capital T. So this is gt square by 4. And then half A, which is how much? G we can take common, and by 2 we can also take common. So 1 minus mu S root 3, right? And this is alpha t square. So how much is this thing? G cancels 4 and 4 cancel. This is t square 1 minus mu S root 3 alpha squared t square. So t squared also cancels. So what do we have? We have 1 by alpha square. This is 1 minus mu s root 3. So mu s is how much? Or root 3, mu s is 1 minus 1 by alpha square. So mu s is how much? 1 by root 3 alpha square minus 1 by alpha square. This is the answer. So they have given 1 by root something alpha square minus 1 by alpha square. So alpha is, or this x is 3. Right. So this was the question. Is this question clear, everyone? So we didn't do anything. This was a simple question, right? We just added this friction, calculated acceleration, and then calculated this mu s. Only the crucial part was that this distance, these two distances were same. So only these were the crucial parts. Right? Is it clear, everyone? Is it clear, guys? Yes, guys, is it clear? Good. So quickly do this problem, quickly note it down. And whenever you guys want me to scroll down, please tell me. And yeah, we have 5 minutes more, so we'll do another question as well. But quickly note down this thing, right? If you guys have any doubt in this one, so please tell me. If you guys have any doubt, please tell me. Otherwise, quickly note it down. Yeah, so quickly note down this part and please tell me if you guys have noted it down. Done. Okay, yes. Rest of you guys, please tell me. Maya has noted. What about you guys? Yes, guys. Done. Yes, Tari, Fadil, and yeah, all you guys are here. So noted,
Yes,
guys.
settled.
Done. Okay, so now let us quickly do. We can do one question, right? More, and then yeah. So let me see this question. You guys have to do right. I will give this question as your homework. This question we can do very easy, right? So don't get afraid by the answers. Question is very, very easy. we have these long answers, but the solution to this question is very easy. So, right. So this block okay. Yes, what happened to this? Thing? Yeah, what is happening? Okay, so which is giving me some problems. Meanwhile, now it is back. So what is happening to this thing? Okay, now it has returned. So we have this thing, right? The force is with some angle, right? So this is the force, which means that it will have two components. So this force will have this component sine theta and this component cos theta. This component cos theta and this component sine theta. Right. Now we can write the free body diagram. So acceleration is A, right? Which means that friction would be in this direction. Friction is in this direction, and we have this normal reaction. Right. Oh, so we have this normal reaction upwards, and then we have mg downwards. So now we can write everything, right? So if we write in the vertical part, Newton's law. What we need to apply, guys? Tell me quickly. Tell me because we have very few time left. I will rush. So just this part is important. In vertical part, what we need to apply? Equilibrium or Newton's law? Equilibrium. So Maria has said equilibrium. So let us apply, which means that upward forces that is equal to downward forces. Right. So N is mg minus f sine theta. So this is N. Now in the horizontal part. Horizontal part, we have to apply Newton's second law. Right. So this is MA. That is equal to f cos theta minus f. So how much is this thing? F cos theta, f is mu s n. Yes, B. So Maria is saying B. Yes, correct. Absolutely correct. So this is f cos theta minus mu s. N is this thing, mg minus f sine theta. So this question was very simple, right, Maria? So if we calculate this acceleration, this would be f by m cos theta minus mu s. M will cancel g minus f by m sine theta. So this is your acceleration. As Maria got this thing, f by m cos theta. So this is the answer. Is it clear, everyone? Is it clear, guys? Tarif and Fadil, is it clear? Yes, Tarif, are you there? Okay, I'm exceeding.
Yes, sir.
Yeah, I'm exceeding your time. Quickly note it down if you guys have any doubt. Please tell me. Otherwise, note it down. and then we will stop here. So in the next class, I will start work energy and power, right? Time to start that thing. Dynamical friction is there, banking of the rope, but that part I will take in the next class. So yeah, that thing I have to take in the next class because we have very few time and we have to cover so many of things. Quickly note it down, guys. Maria has solved this problem, so no need to note it down, Maria, but rest of you guys quickly note it down. Whenever you guys have noted it down, please tell me. Oh, this is mu k, right? This is mu k because that is kinetic friction. The object is moving, so we have always greater than mu k. So we have these are not equal, right? So mu k, this is mu k.
Yes, Adan.